Frequently asked questions for OR interconnection. What are the limiting factors for interconnection? A company's electrical grid has various requirements, and one of the key factors to consider is the availability of utility company interconnections. This availability plays a significant role in determining the appropriate size for the OR system to install. For instance, distribution circuits are usually designed to accommodate the current demand and expected short-term growth in the areas they serve. Utility companies have the option to upgrade the circuit by reconductoring it to increase its available capacity. Ideally, when there's a site close to a substation that feeds 3 to 8 distribution circuits and offers available capacity between 30 and 75 megawatts, it becomes possible to consider a larger capacity OR system. This system can be sized to match the available substation capacity or even a portion of the existing load capacity, if approved by the utility company. This approach can help reduce the utility company's need for self-generation and external power purchases, potentially leading to cost savings and less strain on transmission lines. Ultimately, it may also delay the need for expanding transmission facilities. What are the voltages and frequencies for the OR? Connecting to a transmission line with voltages ranging from 16 to 66 kV can be achieved, using specialty contractors who are certified to work with these higher voltage levels. For voltages above 66 kV, the specialization level increases significantly, and handling such transmission circuits will require a case-by-case approach. This is because these higher voltage lines are typically supported by lattice towers, which demand unique expertise and consideration for each situation. While OR units have a smaller land footprint compared to traditional wind turbines, they still necessitate an electrical collector system, albeit shorter in length. This system consists of lines that connect to a main substation, allowing the generated electricity to be integrated into the grid. Distribution-rated voltage interconnections will incorporate a centralized panel equipped with the necessary circuit regulation devices. This includes synchronizing equipment, VAR compensation, CTs for metering, and a PC interface. The regulated circuit will then feed into a step-up transformer, which is used to elevate the voltage to match the interconnection grid voltage. In essence, the centralized panel and the step-up transformer together function as a substation. Online data provision. OR will build the necessary data transmission facility to provide online data delivery. Online data provision will include status of the main circuit breaker, active power import and export, reactive power import and export, voltage at the main circuit breaker, wind speed and wind direction from the site wind mast. Applicability of online data provision. Online monitoring will provide updates at regular 10-minute intervals. Nevertheless, in the event of a significant breakdown, such as the sudden tripping of the entire system, it will be promptly reported to the System Control Center for immediate attention. Low voltage ride-through capability. If the grid voltage at the point of interconnection drops to 40% of the nominal voltage, and stays at that level for a duration of less than 100 milliseconds before recovering to a voltage level of 90%, or higher within 3 seconds, the OR system will remain connected to the grid. However, if the voltage during the disturbance falls below the mentioned voltage profile, the OR system will trip and disconnect from the grid. Harmonics and flicker. The OR systems will adhere to the standards set by the International Electrotechnical Commission, IEC, for flicker, harmonics, and interharmonics. Specifically, the emission of interharmonic current during continuous operation will be clearly defined. This includes frequencies up to 50 times the fundamental grid frequency, total harmonic distortion, and emission levels of individual harmonics. The goal is to ensure that distortion remains below 5% of the fundamental rated current.